Alright, let's start with a hyperbola. Here, a little graph of a hyperbola. And based on that, we know where its vertices are and where the foci are. We should be able to write the equation for it. And then we're going to go the other way, start with the equation, and show how you would figure out the foci and the vertices. Okay, so here are the standard equations for um, a hyperbola. This is for one that opens to the left and to the right, like the one we have here. If it opens upward and downward, then you switch the y parts and the x parts. So instead of x minus h squared here and y minus k squared here, you would put y minus k squared here and x minus h squared here. Okay, so we're going to focus on uh, a, a hyperbola that opens to the left and to the right. Um, okay, so what do we need in order to write the equation? Um, well, HK represents, I should actually write that on here. HK are the coordinates of the center. Um, A is the distance from the center to a vertex. And B is the height of what's called the fundamental box of the hyperbola. And what we really want is to get C. Or we can find C easily because C is the distance between the center to a focus. And A, B, and C relate in a very specific way. So if we know A and C from the graph, we can easily calculate what B is and put that in the equation. Okay, so let's just write what we know from this hyperbola. So the center is at the point -1 and +1, 2, 3. So HK is so -1, 3. Okay. Where are the vertices? So this point would be so 1, 2, and 1, 2, 3. So that's where this guy is. The focus here is it's just 1 over, so 3, 3. And then where's this guy? So we've got -1, 2, 3, 4, 1, 2, 3. And -5, 3. All right, so so we need A and B, but we can figure out A and C pretty easily just from this information and calculate B from that. So what's A? What's the distance between the center and the vertex? So it's this distance here. Well, if the center is at -1, 3, and the vertex is at -4, 3, then that distance is 3. So A equals 3. Which you can see pretty easily from this. If you needed to, you could use the distance formula if you needed to. Just say the distance from the center to the um, vertex here. But here it's pretty easy to calculate what that distance is 3. So A is 3. C, which is the distance from the center to the focus, is 1, 2, 3, 4. C equals 4. Alright, but C is not part of the standard equation, but we can calculate. What we really need is A and B. We've got A and C, but we can use this formula to figure out what B is. This is the relationship. So C squared minus A squared equals B squared. So C squared is 4 squared minus 3 squared is equal to b squared. So 4 squared is 16. 3 squared is 9. So 16 minus 9 is 7. So 7 equals b squared. And I'll actually just leave it as b squared because that's what's in the equation, b squared. If we were to square root this and say b is the square root of 7, we'd have to square it again anyway to put it into the equation. Okay, so we've got a and we've got b squared. We've got the center. And that's all we need. So let's write our equation. So our equation will be x minus the x coordinate, h, of the center. So x minus negative 1, which is x plus 1 squared, over a squared. A is 3, so a squared would be 9. Minus y minus k. K is 3 squared over b squared. B squared is 7 equals 1. And that's it. That's the equation for that ellipse. Or, excuse me, hyperbola. So what if you were given the equation and needed to figure out how to graph it? And you needed to figure out where are the foci and where are the vertices. So let's do that process backwards. So from this, okay, so the equation is x minus h squared over a squared minus y minus k squared over b squared equals 1. So hk is the center. So from this, we could derive that the center is negative 1, positive 3. Right? Okay, so a squared is 9. A is the distance from the center to the vertex. So if a squared is 9, a would be 3, right? Which we knew from before, right? So the distance from the center to the vertex is 3. Okay, but we don't know if right away if the hyperbola opens upward and downward or left and right. All right. Well, a squared is bigger than b squared. So just by definition. And then so 9 is bigger than 7, so that we know this 9 represents a, right? I guess we should have done this before we calculate. Yeah. Okay, back up. This represents a. Well, if the x business is over the a, then the hyperbola opens to the left and to the right. If this bigger number were under the y, then it would be one that would open upward and downward. Okay, so since we know this is a larger number and it's under the x stuff, then we know this opens to the left and to the right. So we know the distance is 3. So because it opens to the left and to the right, we're looking for going 3 units to the left and to the right of the center. If it were a hyperbola that opened up and down, we'd go 3 units up and 3 units down to find the vertex, right? Well, because we know it opens left and right, we'd go 3 to the left and 3 to the right. So 3 units to the left of this center would be, so if we go 3 units to the left, it would be negative 1, so negative 2, negative 3, negative 4, negative 4, 3. It's going to be aligned with the y coordinate, right? So that's a vertex. The other vertex will be so negative 1, 0, 1, 2. All right. Okay. Now we need to know what C is in order to figure out where the foci are, because if we know where the center is, we can figure out where the foci are based on what C is. So C squared minus A squared equals B squared. We know what A squared and B squared are. So C squared minus 9 equals B squared. So C squared equals 16, adding 9 to both sides, so C equals 4. So if I start at the center and go 4 to the left and 4 to the right, I get 2. So negative 1, and then going 4 to the right would be negative 5, 3. If I go 4 to the right here, I would get negative 1 plus 4 is 3, 3. So this would be one of my foci. This would be the other one there. So we've got the center, vertex, vertex, focus, focus. Sorry, this is getting kind of sloppy. Here's that information again. Okay, so the key is knowing what does A represent, what does B represent, how do you get A, B, or C if you've got the other two, how do you find the center, and then how do you find the vertices and the foci based on where the center is and what the length of A and what the length of C are. All right, good luck.